Hey, it's time for chapter 7. I made a little formula sheet for you, but now that I look at it, it looks a little difficult to read at parts. So we're going to run through this little worksheet, and this is the bulk of chapter 7. This is talking about uniform distribution, and it's talking about normal distribution. In a normal distribution, you have to have a chart, and I'll show you what charts I have. Like, I had to look it up on Google because I don't have my stats book with me. But this one is very nice, right? Don't look at the stuff around the chart. Just look at the thing right here. This is for all the positive z-scores. If you can see on the left, they're all positive numbers. And I got this chart for all the negative numbers. Cool, huh? And again, it has a little picture up here to make me see, oh, this is the negative side versus the positive side. So positive, negative, lovely. Okay. So we need that when we get to normal distribution stuff. But for now, number 1 and 2, I don't need it because I'm talking about uniform distribution. In uniform, you got to think rectangle. That's the idea. So the idea is that if you were to think about probability, like number 1, we're going from 66 degrees, so let's say it's right here. And we're going to go up to 88 degrees. And yes, this isn't in scale. This would be like, this would be bigger, this would be wider, but you get the idea. That the idea is that the probability that it's 66 degrees is the same that is the probability that it's 88 degrees. It's the same as the probability of anywhere in between. And so all of these probabilities are up here forming a horizontal line. And if you draw a line down to the numbers that are at the edge, 66 and 88, it creates a rectangle. Now, what do we know about the area of a probability distribution is that the area is equal to 1, always. So if the rectangle, we have length times width. If length times width is equal to 1, then knowing this, which is 22, will help me find the height or the width. In this case, we get 1 over 22. That's what he is up here, 1 over 22. And you could just find out what that decimal is if you want, but I'm going to leave it as a fraction. Okay, so uniform means draw a rectangle, and that rectangle, you know how far to draw it left to right. You just need to figure out what the height is. And none of this is to scale. It's just to give you an idea of what was going on. So if I were to say, what's the probability that I pick a temperature randomly between 66 and 88, the probability would be 1. That's what it is. It's uniformly between those two. But if I said, what's the probability that I pick a random one that's exceeding 71 degrees? So what I'm talking about is a probability that x is greater than 71. Exceeding. Well, somewhere around here is 71. I'm going to say like right here. And from 71 to 88, which is everything bigger than 71 within this rectangle, that would be 17. But the height stays the same. It's always 1 over 22. So the probability would be 17 times 1 over 22. And if I put it together, I get 17 over 22, which is a fraction. And if I write the decimal, it's 0 point something, which is in the answers, 0.7727. I don't have a calculator handy, sorry. Okay, that's how you do number 1 and number 2. So let's do number 2. Look at it. And again, I'm going to draw a little thing. You don't have to draw this part. You can just draw a rectangle and then deal with it. So the rectangle for number 2, it says it goes over 8.5 to 11.5. So this total distance is 3. Right, the whole thing is 3. That means that this height is 1 over 3, because that's how you would multiply those two to get 1. And again, whatever this length is, it's 1 over that number is the height. Much quicker than this business. All right, so we want the probability that you get between 9 and 10 gallons. So 9 less than x, less than 10. And yeah, you can put little arrows underneath here if you want, but between 9 and 10, I don't know if it's strictly between or not. It doesn't matter. Same probability. So what I'm going to say is I'm going to figure out what this distance is from 9 to 10. Let's see, this is from 9 to 10. That's 1. 1. So 1 times 1 over 3, which is 1/3. And that is equal to 0.333333333333. You get it? Okay, so remember, uniform means rectangle. Number 3, we're going to talk about some theory on the normal distribution. And they give us a nice little curve at the beginning, which I'm horrible at drawing. But the thing to know about the normal curve is that right smack in the middle, at the highest point, is the mean. So the mean in this is -6. And if you'll see the chart, focus, there we go. It's right in the center, -6. Now the other thing is the standard deviation, and that is this line right here. It's where the concavity changes, if you remember that from anything in your past. You don't have to know that. This is a little thing. So the standard deviation, one standard deviation is the distance between -6 and -4. And what's the distance between -6 and -4? 2. Right? Number 4 asks us, what is it symmetric about? And this is a definition, mean. Number 5 asks us approximately what percent is between -2 sigma and +2 sigma. And if you remember the empirical rule, then you might know it. But if you don't remember the empirical rule, it's on the formula chart sheet that I have. Between -2 and +2 is 95%. Okay. And number 6, 7, and 8. All right. So that's just a little bit of theory to make you a little bit more comfortable, hopefully, with the normal distribution and what it means. The mean is in the center, and then each one is a sigma away. And you can find that by subtracting. That's that one. The mean is the center. And then the empirical rule, remember, it's 68, 95, 99.7. That's 1, 2, and 3. You don't have to remember it, actually. You're working at home. Who's to say you're looking at something while you're doing problems? Anyway, so here we have, they give us z is equal to 1.5. And they want to know, what is the area to the left of it? Well, if we're looking at the left, all we got to do is look at the chart. So let's pull up the positive 1.5 chart. Here, I'll show you. So it's good that we have this little video that way you can see me using the chart. So along the side are the z-scores, but so are along the top the z-scores. It's just the second decimal. Notice it's only the second decimal that changes up here. So if I have 1.5, that's like saying 1.50. So that first column, 1.50 is going to be 0.9332. Well, let's go back. So let's say I had 1.25. I would go to 1.2, but then I would go all the way over to the 5 column. See, 5. So 1.2 and 5, 0.8944, right? So that's the idea. So they only want 1.5, so we're going to go to the left of 1.5 is 0.9332. And that is all I have to write. 0.9332. Okay. Number 7, they give me the z-score is negative 1.25. And I'm going to the right. So in this case, when I'm going to the right, I tried to write this on the formula sheet in such a way that would make sense, but I don't know if it makes sense for you. So let's talk. So this is to the left. Anytime you have a number less than an x less than a number or z less than whatever number, you're going to just use the chart like I just did for this one. But if you're looking at something to the right, bigger than, then you got to say 1 minus the chart number, which is less than. So both of those charts are less than. So if it's to the right, we're going to go 1 minus the area I find on the chart. All right, so negative 1.25. I'm going to go to the negative chart, which is this one. negative 1.2. Don't forget I go over to the 5 column, so this one. Negative 1.25 is 0.1056. 0.1056. So 1 minus 0.1056 should give me my answer, which is 0.8944. Okay. So to the left, just use the chart number. To the right, find the chart number and then say 1 minus that. And then for between two numbers, which is what I think this next one is. Yeah. So we got between z equal to 1 and z equal to 2. So this idea is on the formula sheet like so. So we're looking at numbers between, x between or z between. We're going to take the probability of the chart for the right number minus the probability of the chart for the left number. So right minus left. So we're going to say probability, the area for 2 minus the area for 1. Those are the two z-scores I'm dealing with. All right, so I just need to go to the positive chart. Every time I got to refocus, but you know what? It's worth it to show you. So 2.00 is going to be 0.9772. 0.9772. And then, 1.0 is 0.8413. So 0.8413, right? 8413, yeah. All right, and all I've got to do is subtract those two. So I get, I don't know, 9, 6 minus 5, 7 minus 4 is 3, 1, 0.1359. Okay, and now I'm going to take just a minute to go down and check these answers because, you know, as you do problems, you don't want to wait till the very end and check. I like to check as I go, but these three kind of went together. So 0.9332 is correct, 0.8944 is correct, and 0.1359 is correct. Yay, so far so good. So that's the idea, is that if you have a z-score and you want it left, that's the chart. If you want it right, 1 minus the number, the chart number. And if you want between, you find the area of the bigger one minus the area of the smaller one. Subtract. Okay. So that's what 9, 10, and 11 are asking you to do, but instead of giving you z-scores, they give you x-scores. So x, they want the probability that x is less than 90. I saw it at the very end of that problem. And so what they want you to do is convert this to z-score. And you do that using this lovely formula, x minus mu over sigma, right? And so in this case, x is your 90. That's the idea. That's where you get your x number. Even though, yes, it's x smaller than 90, for the purposes of finding the z-score, we're going to use 90 for x. So we got 90. The mu in this case is 80. That's what they said. They even wrote it like that. And the sigma is 8. Standard deviation is 8. So this is 10 over 8, and that reduces to 1.25. So really what they want is the probability that z is less than 1.25. And less than means use the chart. Yay, so it's nice and quick. So let's pull up our positive chart. I'll do this with you. All right, and then we got 1.2, gonna go over to 5. Is that right? 0.8944. 0.8944. Shoop, 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 shoop. So the probability that the z-score is less than this, 1.25, is the same exact probability as x less than 90. Because that's what normal distribution z-score does. It finds an equivalent, and then it gives you a chart to look up. Chart number to look up. Number 10, we want the probability that x is bigger than 126. So again, this is going to be one of those right side, and we're going to say 1 minus something, right? So we're going to say 1 minus the probability that x is less than 126, which is the same thing as saying 1 minus the probability that z is less than something. I don't know. So let's go down here and do the z-score. The x number is 126. The mean is 110. And the sigma is 20. All right, so this is 16 over 20, and that reduces to 4/5, which is 0.80. Z-scores are typically 2 decimals. That's why I wrote it like that. All right, so I just got to find the area for 0.8. Let's go to the positive thing. 0.8 is 0.7881. Come on, focus. There we go. So we got 1 minus 0.7881, right? 0.8, yeah. And so I subtract it from 1 and I get 0.2119. Right. Number 11. This is probably the between problem. Yup. So we got probability that your x is between 57 and 105. So I got 2 z-scores to find. The first one is 105 minus the mu, which is 90, divided by the sigma, which is 12. All right, this is 15 over 12, right? 10 plus 5, yeah. And then this reduces to 1.312 is 1/4, it's 0.25. Okay. Second z-score is for 57. So we say start with 57 minus 90, and that's all over 12. So the same mu, same sigma, but the number changed. Now, here's the thing. You're not seeing this. Okay, here we go. So here's the thing. When we subtract, so far we've always had positive answers. But in this case, because 57 is smaller than the mean, we're going to have a negative. Don't change this order. Keep it the same. X minus mu. Always x minus mu. Because negative numbers matter. What is this? Negative something, 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 something. Negative 33. Okay, well that goes 2 times, and you're left with 9/12, which reduces to 3/4, so negative 2.75. Okay. All right, so what this is asking for is the probability that we're going to say z is less than the bigger number, 105, and that goes with 1.25, minus the probability that z is less than the smaller number, which is negative 2.75, sorry. Okay, now remember this is from the chart. If it's between, you're saying the probability of the bigger one minus the probability of the smaller one. And this is the bigger one and this is the smaller one. Okay. Okie dokie, so let's find these chart numbers. One of them's positive, so let's go to this one. This guy. Well, this is 1.25, so 1.2, oh wait, I've done this before, 0.8944. Okay, 0.88944. And then let's go to the negative one, boop. And I want negative 2.75. Well, there's negative 2.7. I'm going to go over to 0.05, and that's 0.0030. 0030, okay. All right, 0.8944 minus 0.0034, you would get 0.8914, I guess. All right, so I got 3 answers. Let's check them. 9, 10, and 11. Come on. 0.8944 is correct. 10 is 0.2119, yep. And then 11 is 0.8914. Good, all right. Zoop. So that is a lot of what we're doing. Just finding a z-score and then using the chart correctly. Number 12 is a word problem, so is 13. But both these word problems are asking you to translate into this type of problem. So first of all, I will look and I will write down some stuff that they know. Let's go to this. Let's go to the last sentence. It says find the probability that the bottle contains fewer than 12.06. So whatever's going on here, I don't know. But it's a probability that something is less than 12.06. That's what they want. So like this one. Hey, that's nice because all we have to do is look at the chart once we find the z-score. So I need to use the z-score. 12.06 is my x. My mu, they say the mean of 12.16. So that's the mean. And then the standard deviation is 0.04. That's the sigma. Right, so this number is in the word problem. This number is in the word problem as mean and standard deviation. So we subtract, and we get a negative 0.10 over 0.04. And then that becomes negative 10 over 4, which is negative 5/2, which is negative 2.5. All right. Trying to do this in my head, so correct me if I'm wrong. Oh, wait, you can't. Well, I guess you could send me an email. I read those, by the way. So if you ever need help, send me an email, and I read them. And believe it or not, my sleep schedule is messed up beyond repair. So if it's 3 in the morning and you want to send me an email, I'm probably awake. Okay. Z less than negative 2.5. So I'm going to go to the negative chart. Beep, 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 beep. All right. Negative 2.5 is 0.0062. So the answer is 0.0062, right? That's a very low chance that it's pouring less than 12.06 ounces. And that's good, because you don't want it to be pouring too much less than the mean, right? That'd be bad. All right, number 13 asks you the same type of question, only here they're asking you, find the probability that the bottle contains more than, so x is greater than 12.14. Okay, same problem except now it's greater than, so we're really going to be 1 minus the probability that x is less than 12.14. So the chart number. So let's find a z-score to go with that. 12.14 minus the mean, which is changed to 12.14 here. What? Standard deviation is the same. And look at here. Up here we get 0. And 0 divided by anything except for 0 is 0. And if you want it in a z-score, it's 0.00 because it's usually 2 decimals. Right? So what's the number that goes with this? So it's 1 minus the probability that z is less than 0. Well, if you remember about the normal distribution, mean, standard normal, the mean is 0. That means right in the center. So everything to the left of center is half of the area. And that half is 0.5. And 1 minus 0.5 is still just 0.5. Okay? Now you can use the chart and look that up just to confirm. But if you do, go to the positive chart, look up 0.00, and lo and behold, it says 0.5000. Okay. All right. So starting you off with z-scores, then hitting you with x-scores, and then hitting you with a word problem. That's me trying to get it to where you can use statistics in real world, but not right away and making you get lost. You're going, what is this word problem? Ah! Okay. Number 14, we're going to go backwards. So find the z-score for which the area to the left is 0.4. So now they give us the area is 0.40. And they went to the left, so they went left. And that means chart number. But it's going to go backwards. So instead of that, let me just look up this one. So I know that right in the center is half. If you go from all the way... Okay, focus now. Can you focus? There we go. So if you go from here all the way to the center, that's half of it. So if the area is 0.4, it's going to be less than half, which means we're in the negative z-scores. Does that make sense? Because if it was bigger than 0.5, we'd be over here. But since we're less than 0.5, 0.4, we're over here. Now, the thing is, we're going to try to find 0.4 somewhere in this area, and then we're going to go out to the edges to see what the z-score is. and that's backwards from what we were doing. Now, I don't know if you see it, but it's probably the closest. So negative 0.4013 is slightly closer than 0.3974. This is like 0.26, and this is 0.13. So yeah, this is the closest one, I think. So we're going to go, it's negative 0.2 over here, and it's 0.05. So it's negative 0.25. Negative 0.25. That's it. And we always start you off with a nice one, then go to the next one, which is not as nice, right? So this is just looking in the chart for 0.4 and then give me a z-score that goes with it. Number 15, it says, find the two z-scores that separate the middle 87.4%. So this one's not easy. I tried this a couple of times and I was screwing it up. And I'm going to draw a little curve for you because, you know, I love you. All right. So here we got this number and this number. I don't know what they are. This is negative z and this is positive z. And it's the same number, only one's positive and one's negative. I just don't know what that number is. But I do know that the area in between them is 87.4% of 1, and that's 0.874. Now, if I go look up 0.874 in the chart, I'm going to find something that gives me everything to the left of some other number that's equivalent in area to this. So looking this up is not going to work. We have to do something else. What I would do is see how it's kind of divided in half by the mean, which is at 0. So what I'm going to do is I'm going to divide this number by 2. I'm going to get 0.437, I think. Yeah, 0.437. Now that's the area here, and that's the area here. Now what I can do is I can think about, okay, if I knew this area, which is 0.437, and I know that everything to the left is 0.500 or 0.5, then I could subtract the two to get this area. Now, you don't want that area for your answer, but knowing this area will help you figure out what this z-score is, right? Because that's how it goes. If you know the area to the left of a number, then you can find the number that goes with it. So I don't know, I can't do it with this number, but I can divide it in half, and I can subtract that number from 0.50 and get 0. Let's see, that's 3, that's 4, 9, 10. 10 minus 7, 9 minus 3 is 6, and 4 minus 4 is 0, 0.063. That's what that area is, 0.063. Okay, so I know I'm in the negative z, so I'm going to go to that chart, negative z chart, and I'm looking for 0.063, 0.0606. Oh my God, there it is, 0.063 in the flesh. How the hell are you, 0.063? Sorry. All right, so it's negative 1.53. Negative 1.53 is that z-score, and that's one of the z-scores I needed to know. The other one is the positive one, 1.53, because it's symmetric. So there you go. Those are the two answers for that one. That was a tough one, not one I put on the quiz, so don't worry about it if that didn't make much sense. Number 16, it says the amount of corn chips. Is this the last one? Sure is. All right, so the amount of corn chips, blah, 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 blah. What does it say at the end? What chip amount? So again, they want an X value here. So what chip amount represents the 67th percentile? And I don't know if percentile means percent. So again, they're giving me 67%, but it's not between two numbers. It's going to be on the left of the number. So if I'm looking at this normal distribution again, where in the center is 0, then 67%, this is 50%. 67% somewhere like right here. And that area is 0.67, right? Well, that's the area to the left of this z-score. So I just need to figure out what this z-score is. And then I'm going to use this formula right here. Z, sigma, and mu, all to find out what x is. All right. So first, let's start looking for 0.67 in that chart. Now I want the positive one, so let's go to the positive one. Let's focus in on this so you can see. All right, 0.67. Oh my God, there it is. How are you doing? Hey, yeah, buddy. All right, sorry. 0.44. 0.44. So this z-score is 0.44. And they wanted z-scores in the last problem. Here they want the x amount. They want the number of chips. Number of corn chips. So we're going to use x equal to sigma times the z-score plus mu. That's that formula. All right, so we're going to plug in sigma, and it tells us the standard deviation is 0.2. The z-score we found is 0.44. And the mean, they tell us, is 32.5. So all I got to do is multiply those two, add it to that, and you get the answer. Now I got to pull up my calculator. Hold on just a second. Because that's a little bit out of my ability to do in my head. 0.2 times 0.44 equals, and then plus 32.5. And that should be giving me 32.588. Which, where they say they wanted to round to the nearest hundredth. So that's this number, so we're going to round that to 32.59. Let's look. Yeah! All right. Thanks for joining.